Hey guys, welcome back. We are now moving on to a presentation by Yuriy Belenitsky. This is my pleasure to introduce this presentation, not just because it's related to Buildfarm, but because I was Yuriy's direct manager back when we were working together at Uber ATG. Looking forward to hearing how things are moving over at Aurora. And take it away, Yuriy.
All right, sounds good. So my name is Yuriy. I work at Aurora. I'm a software engineer on the CICD team. And I wanted to give this talk to share my experience in deploying and running Buildfarm back in the Uber ATG days and now at Aurora as well. So a little bit of a history here. We started with Buildfarm very early on, since back in the day when George first wrote Buildfarm. And in about 2018, we decided to move our data center Buildform Deployment to the cloud. So I sort of volunteered to take on that effort, and that's where my journey with this began. So we started from scratch. We had a ton of issues. The initial deployment was just like a full-time job to constantly babysitting, restarting servers, and just not very straightforward. So our initial deployment, we used CloudFormation and we deployed directly on EC2 instances in AWS. Then down the road, we did move to Kubernetes, and the deployment became much easier to manage. So after ATG was acquired by Aurora, I sort of was tasked with this same effort again. And that was my journey part 2 began. So I'm going to concentrate this talk on sort of combining the lessons learned from both deployments, the one at Uber ATG and also the one at Aurora. So there will be some elements from both. So this is what our deployment looked like at ATG. It was we had 5 different clusters. We had Dev and Stage, which were mostly for developers to use, which was mostly just the build team, and Stage we used for sort of prep work before we went to production. Our production clusters were very large. As you can see, we had 3 clusters. We had the main one where we burst up to 10,000 CPUs. And we had the other 2 that were handling the submit queue only, and one of the build flavors that caused some cache thrashing in the main cluster that needed to be separated. Now, the Aurora deployment is much more manageable. So we still have the Dev and Stage clusters. They're about the same size. And we only have 1 production clusters right now. And the main reason for that is our cache rates are much better. So we do not require as much execution capacity as we did at ATG. This is sort of a diagram of what our main deployment in AWS looks like. We have clients, which could be the build kite machines or developer machines that hit the Route 53 endpoint, which then in turn hits the network load balancer. And then we have an auto-scaling group set up for servers and CPU workers, GPU workers. We use Elasticache Redis cluster. And all of the nodes have Prometheus scraper installed in them to collect the metrics. And we also have a Buildform Admin set up on servers, which I will talk about later. Now, one of the challenges we had was what happens when we need to duplicate our Buildform cluster. So let's say we had 1 production cluster, we need to add 2 more. Back in the day, it was extremely painful until we put everything in the Terraform module, and this is all that's required to duplicate one of the clusters. So we do use a single region and single availability zone deployment. And I think one of the previous talks talk about the latency, which is what this accomplishes, is provides for minimal latency. We also don't have to worry about any charges for between accounts or between regions or availability zones. Now, the downside, of course, of this is that we run into instance availability issues and we don't have redundancy. So our load balancer, we chose to use network load balancer because it does provide full HTTP2 support. Now, the application load balancer now provides that as well. It did not back in the day. But the other reason is single availability zone usage. We tried to use Kubernetes service, and there was some issue with IP tables where we were dropping connections, and it just didn't work right. And some of the other connectivity issues we may have are due to DNS or misconfigured security groups where you might not have access from certain offices. So we do use Elasticache Redis. Currently, we have a fairly small instance. We've had, in the past, we did use a much larger cluster. We use 3 shards. Currently, we use version 5 Redis. Some of the older versions, I believe version 3, did not respect TTL, so we constantly had to run scan to remove all the old keys. We do have to run an indexer. I don't know if anybody's familiar with it, but it is actually in the public repo right now to prune the workers that no longer exist. Now, I have a pretty big slide here on the choice of CAS. So we've used both. We've used EBS and we use the attached SSDs. And what we found is that EBS is just too slow. Like here, I have a comparison between roughly the same size volumes. And you can see that EBS just does not provide the same amount of performance as attached NVMEs do. So what we end up deciding is we use a pretty large instances that have 4 900 gig volumes attached to it. We rate them together to give us a 3.6 terabyte volume that we can use for our CAS. And from real world performance, provides about a 30% improvement. Now, this is extremely important to also use for clients because that not having SSD on a client is going to be your bottleneck for I/O. And from cost perspective, as you can see, I compared 2 different instance types with the same specs. One of them uses EBS volume, the other one uses attached SSDs, and the monthly cost is roughly the same. So what does our CICD pipeline look like? So we currently build nightly. We pull the latest from public repo. We do have a private repo set up that contains all of our configuration files. And we have a build kite pipeline that ends up building based on those configuration files. And it pulls the public Bazel Buildfarm as a dependency. We do use Spinnaker for our deployments. It works really nice. We automatically deploy to dev. We do validation. If everything looks good, we go ahead and manually promote to stage once we're ready to release a new version to production. If everything looks good on stage and it passes all our testing, we at that point roll everything out to production. We do all the testing there. If something doesn't work right, we can hit a button and roll it back. We also use this pipeline to do public Docker image releases, which go in a Bazel build Docker Hub. So metrics. Metrics are extremely important. We use metrics for auto-scaling. We use metrics to detect bad workers, see what our cache hit rates are, see what the load is on a build farm at any point in time. And like as you can see here on the bottom, it shows a graph with a flat line So that's our detection mechanism that tells us that we have a bad worker that needs to be terminated. So I'm going to talk about a little bit about cost. So what does this thing actually cost, and where do all the funds go to? As you can see, by far, our CPU workers are the main expense, followed by Redis, and then followed by the network traffic. So no matter how much funds your company tells you you have to deploy Buildfarm, at some point they're going to come back and say you need to cut costs. So how do we do that? One of the biggest cost-cutting tools we have is auto-scaling. And there's a couple different things you can do here. So we can do a daily schedule where, let's say, our load starts at 9 a.m. Let's scale the cluster up. And at 9 p.m., let's scale it back down. It works okay. It doesn't quite cut costs as much as you may want to. So the better thing to do would be use load-based scaling. Then you can utilize your metrics, and when demand creeps up, you scale up. When it goes down, you scale down. So that works great, with the exception of the case where your morning loads increase pretty drastically and you're not ready for it. So the best thing to do is use the load-based scaling and also scale up for your daily loads in the mornings. And that's what we've been doing, and that seems to work really great. We do scale our CPU, GPU workers and our server nodes independently. So each one of you uses a different set of metrics. And from what I learned, it's always better to scale up pretty aggressively and do more of a gradual scale downs. So one of the challenges that I personally have with running Buildfarm is try to anticipate load a little bit ahead of time. So before you actually need that capacity. And one of the personal projects that I'd like to take on at some point is maybe use machine learning to try to anticipate the load. I played around a little bit with anomaly detection in AWS, but it doesn't seem to work as well as I want it to be. So here's the other way to control your costs, is you can utilize Spot. So Spot provides for about 70% savings versus on-demand instances, which is pretty cool. But of course, it's not all great. So there are some downsides. The downsides is that at any point in time, those instances can be yanked out of you, and you lose a large portion of your CAS. So one of the ways to sort of lessen that impact is to utilize mixed instances policy, which will provide you for a wider range of different instance types to run your Spot. And the other thing you can do is maybe not utilize Spot during the day because the capacity may be not quite there, but utilize it overnight time when you have less demand overall, where you can maybe tolerate higher losses there. And you can also limit your percentage of Spot. In AWS, you can adjust the Spot percentage. Say like you only want to utilize 50% Spot and 50% on demand, so you're not hurt as much when you have instance losses. So next, I want to talk about two different tools that we use to help us run our Buildfarm deployment. So one is called Belfar Manager. So this is the tool that I wrote and open sourced sometime last year. And what that lets you do, it's a web-based app where you can easily stand up a sharded Buildfarm cluster on your local machine simply by running a couple lines here. It will download the binary, it will run it for you, and it will create 3 separate containers with a fully working Buildfarm cluster. You're also able to deploy this in AWS as well. So you can run it on your own machine, and it will deploy a fully working Buildfarm cluster in AWS for you as well. The other tool we use is called Buildform Admin. It's an internal tool we wrote. It provides for GUI for where you can see all of the hosts you have running in AWS, their uptime. You can reboot or terminate them. You can scale your auto-scaling groups. We also use it to provide some BAP ingestion, and it had a REST interface to provide some administrative tasks via like external monitoring systems. It is currently AWS only, but the way it's architected, we could pretty easily expand it to GCP. All right, so really the main takeaways here are metrics are important. You want to be able to detect your bad workers and so on. You have to control your costs, streamline your deployments, make sure you have the easy way to do rollbacks, utilize hosts with NVMe for performance, and you have to improve your cache hit rates. It is also important to run your indexer. Again, we run it. We run the indexer from Buildform Admin right now, but it has been added to the public repo at this point. And building near infra is always important as well, unless you have direct connect. And I do have some references here. If you do want to try out Buildform Manager, there's the repo for it. Have some AWS references. And we recently added a ton of metrics to Buildfarm. So there's also a wiki page on that gives a description of all the metrics. And that's about it for this presentation. And if there's any questions, let me know.
Yeah, sure. Great job, Yuriy. So I got a couple questions from the audience. First up, do you have any theory for why the aggressive scale up or gradual scale down works well beyond the gut feeling that you have?
So usually what happens with us is we might have certain times, like say around lunchtime or like at 5 p.m. when people go to lunch or people ready to go home, and everybody just submits their builds. And we have this pretty high spike in load. And what we found out is maybe instead of adding like, say, just like 10% of capacity and then waiting another 10, 15 minutes, adding another 10%, it's better off just to add like 25%, as the loads will just be like, we're just never going to catch up if we're not aggressive enough. And scaling down less aggressively works better because as you start scale down and kill off hosts, you start losing cache entries. So it might cause some of a thrash with the scaling.
Awesome. I remember or rather had almost forgotten the pre-lunch spam.
Yeah.
Next question is, are there plans to open source Buildfarm Admin?
Yeah, so that's been a popular question, and George, I know me and you talk about it pretty extensively. So I do want to integrate a lot of the Buildform Admin functionality into Buildform itself. Either that or try to open source it as is. It's still sort of pending, but it's in the works.
All right, last question that we have here. Why is the cache spread out across all workers as opposed to having a small number of dedicated storage nodes? Excuse me. Amazon offers EC2 instances with NVMe that are a lot cheaper than the R5D.star per byte of storage. For example, the i3EN stars. That way workers can downscale without losing any cache contents.
So we don't have the concept of execution only and cache only yet. I think that's something we're working on right now to introduce another pool of workers that are storage only. But our workers that act as cache are also the workers that do the execution.
Awesome. I can personally say that yes, those particular configurations are actually in the works. They're part of our roadmap for 2021. And I want to thank you, Yuriy. I really appreciate you presenting here and all the questions from the audience. Thank you, Yuriy. Appreciate it. And we'll be back with you guys in a little bit.